So let us look at the windings in a little detail and see the reason why we need to cool the transformer winding. So as we all know, the transformer windings, they are made of copper wires, okay? So these copper wires, they have some level of resistance, as we acknowledged earlier in this training. So that resistance that the transformer winding possess, of course, when current flows through it because of the loading, there is bound to be some power losses, okay? So, and that power loss is what is given by this formula, I square arrow. So it is called the I square arrow losses. So as the current that is flowing through the winding is increasing as you are loading the transformer, of course, the losses will also be increasing. That means more heat will be generated. So that heat, we need to remove that heat. So there are situations where ordinary air can actually do the cooling. That is, the air in contact with the transformer winding will conduct the heat away from the transformer winding. In some smaller transformers, that one is enough, okay? But as the transformer is getting bigger and as the loading is getting bigger, I is getting bigger, the power losses is also getting bigger. So we need a more effective means of cooling that transformer, okay? So that transformer that we use natural air conversion to cool is referred to as the cooling system in that transformer is referred to as air natural or air cooled transformers. So now, since the power dissipated is the energy dissipated is increasing with size and loading, we need a more effective means, as we said earlier. So we may now use either forced air instead of allowing the air to cool the transformer naturally, okay? So that's why you see some of these air-cooled transformers, they have fans that help to force the air through the windings. Then there are some, as the size is increasing, the loading is increasing, the heat dissipated is also increasing. So that forced air will no longer be effective. So we need more effective means. So what is this effective means? Is by immersing the transformer winding in oil, okay? So in that case, it's as we explained earlier, when we were explaining the transformer cooling system, okay, the oil remove the heat from the windings. So those oil molecules that are in contact with the windings extract the heat by conduction, and as they get heated up, they move away by natural convection to the tank of the transformer and gives all the heat to the tank of the transformer or the body of the cooling fins of the transformer. Okay, so when you look at it, you see that we have natural movement. The oil conducts heat by convection, by conduction, and then by convection, the oil molecule moves away. Okay, so that is a natural movement. So that is oil natural. And then the oil molecule now gives all the heat to the tank of the transformer. And then air molecule in contact with the tank of the transformer on the outside in the environment, okay, conducts the heat away from the transformer and also moves away for cooler air to come in. So that is natural convention too. So such an arrangement of cooling is known as the oil natural and air natural, which is called the Onan cooling. Okay, so this is the this is the cooling phase. This is the transformer winding. Okay, transformer winding, heat can be generated here, or the heat losses within the core too. Heat can be generated here. So all those heat needs to be removed. So the oil that is covering everything inside the tank conducts the heat away and moves into all of these cooling fins and gives the heat to the surrounding air. So this arrangement is known as, this is the complete transformer showing us the cooling fins, as you can see. Okay, there are openings within each of these cooling fins that oil can go into to increase the surface area of contact between the oil and the transformer, the fin or the cooling fin. Okay, so and this also serves as a means of trapping the air so that the air between these fins can conduct as much heat as possible from the fins as those radiators. Okay, so what we have just described is what is referred to as the Onan cooling. Okay, so on your transformer nameplate, you will see it as Onan. Okay, type of cooling or the cooling system is Onan. Oil natural, air natural. So this is the arrangement. The oil that is in the tank covers the transformer winding and the core. So as heat is generated, the oil molecule conducts that heat away from the winding. And naturally, by convection, it will move away from the source of the heat, okay, after conducting heat. You know, the molecule will not gain enough kinetic energy to move away. So cooler oil will come, so the hotter oil will move up, okay, and then the cooler oil will drop down. And then as it's moving away, it moves into the radiator fins, okay? And then in the radiator fins and on any part of the transformer too, it gives off that heat to the body of the transformer. And then the air around the transformer removes that heat from around the fins or around the body of the transformer. So we also have other cooling system too. Like we said, as the size is increasing, the amount of heat that is generated will also increase. So as that heat is increasing, we need a more effective means of removing that heat. Okay, so the oil natural, air natural may not be too effective. So we need to force air through the fins of the cooling system of the transformer, as you have in your car radiator. Okay, so these are the fans that you see, okay, that you are seeing here now on your screen. These fans, they help to either extract or blow air through the fins of this transformer. So as you are loading it, like on this case now, when the load is light, there may not be need for these fans to come on. But as you are loading it to capacity, okay, when we have more heat losses because of the I square arrow effect, okay, there will be need for more effective cooling, and all of these fans will come on, okay. So this type of cooling system is called the oil natural because the oil within the tank is allowed to flow naturally through natural convection. Okay, so and then the air outside is forced through the fins of the transformer radiator or the cooling fins of the transformer. So this kind of cooling is known as the oil natural air force because you are forcing the air. Okay, so there are others where we may need more effective cooling means we may need to force the oil, okay, through the oil pump. That is with an oil pump through the transformer windings, okay, as you can see here. So this pump actually helps to force the oil through the windings, then into the fins of the transformer. And then we also have air forced through the transformer radiator, okay, or the cooling fins. So you see that we are forcing oil and we are forcing air. So this type of cooling system is known as the oil force, air force cooling system of your transformers. Okay. So we also have the oil force, water force, where the transformer oil is pumped into a heat exchanger instead of allowing the air, okay, to come naturally. We will now have, instead of air, we'll have the oil flowing through heat exchanger that is cooled by water. So as it is flowing through the fins, the water that is flowing through the cooling water that is flowing through the heat exchanger, okay, removes the oil. It does not, it removes the heat in the oil. It does not come in contact with the oil. So as you can see, the oil is flowing through a different channel within the heat exchanger, while the water is flowing through a different channel. So they don't come into contact. So as the oil is giving up the heat to the body of this tubing, okay, the water that is flowing through the external part of the tubing collects that heat from the external part of the tubing and take that heat out, okay? So this kind of case, especially when we have the oil forced through we have an oil, water pump forcing the water through the heat exchanger, and then we also have an oil pump forcing the oil into the heat exchanger and also through the transformer windings. So such an arrangement is known as oil force water force cooling system. So you will see all of this on the nameplate of okay, so you see all of this on the nameplate of your transformer. So like we said, there are other protection systems on a transformer to protect the transformer against overload, which may be caused by excessively loading the transformer, okay? Time more load than it can actually accommodate. So there are systems that when the transformer is overloaded, okay, can cause the tripping of that transformer. So such a system have components that look at the load on the transformer, okay? That is the current flowing through the line, the load on the line. And then if it is more than what it is set for, it can cause the tripping of the transformer. So we also have protection against earth fault. We also have protection against excessive voltage surge. We know that once there are voltage surges, what will be induced in the secondary will also, in the primary, what will be induced in the secondary will also increase. You know, it's a transformer, and the transformation ratio is constant. So when something very high comes into the primary, of course, what will come out in the secondary will be a reflection of what comes into the primary, okay? So such surges can cause the destruction of equipment tied to that transformer or the line itself, okay, since we are still in the transmission line, and even up to the distribution system. So we have a system that look at the voltage, okay, of the line that is through the, as we explained earlier, through the potential transformers. And then if we have excessive or we have voltage surge, it can send a signal to the circuit breaker to open the circuit up. So we also have faults, protection against faults in the tap changer. So because of the fluctuation of the input voltage, okay, that may result to also fluctuation of the output voltage, and we need a steady voltage output. So the tap changer helps us to regulate the output voltage. Okay, so once the input voltage increases, we tend to reduce the number of turns, okay, of the primary voltage that is supplied so that the output will reduce. Then if the output decreases, we increase the number of turns by increasing the tap, okay, the number of turns by changing the tap to a higher level, okay. So that will tend to increase the output voltage from the secondary. So internal faults too, as we'll see later, we have protection system that helps to protect internal faults within the transformer winding. as we'll see later, the Bucos relay, okay, helps us to protect the transformer against some of these internal faults. But on larger transformers, we have uh, protection system tied to the windings themselves internally to help us to look at the windings, and once there are problems, it will help us to protect the transformer against such internal faults, okay? Like the differential protection systems that helps us to look at the current that is flowing through each of the phases, compare each of them. So once there are shortages, you see that, or once there are excesses, or once there is a short of a particular phase to ground, you will see that, or within that particular phase winding, okay, that differential protection system will trip and protect our transformer against such faults. The incipient faults that are developing, we also have protection systems that protect the transformer against incipient faults. The Bucos relay is one of such that helps us, as we'll see later, okay? So as the fault is developing, the Bucos relay will give us a warning signal that there are developing faults within the transformer. So we have the thermometers that helps us to look at the temperature of the oil within the transformer, the temperature of the windings, okay, and also the temperature at the bottom of the transformer, okay. So all of these, they are means of protecting. So as the transformer is also getting bigger, we may have a need to have a gas analyzer on the system that will help us to analyze the gas, okay, that is coming out. That will give us a clear idea of what is happening, especially within the windings, okay. So those are some of the protection systems you will see. So we also have this is called the arc on, that helps to also protect against voltage surge or voltage spike that will be caused by lightning. These are for smaller transformer. On those bigger and transmission transformers, we have independent units on the line to the transformer that protects against surge. But the function of both of them, they are the same thing. So you see that this arcing horn, the upper part is connected to the live part of the transformer. Remember, this is a bushing. Yeah, this bushing is to insulate this live part from the body of the transformer, okay, or the non-active part of the transformer. So now, once there is, and then the other part of the arcing horn, okay, you see it is connected to the frame or to ground, okay, of the transformer. So between here and here, there is an insulation, okay, caused by air that is between that gap. Okay, so the dielectric strength of the air molecule between that is between the contacts of the arcing horn is strong enough to withstand the voltage to flow, or voltage to force charges of current to flow through to ground. Okay, so there won't, in normal conditions, there won't be any flow, okay, because the insulation or the dielectric strength of the air molecule between these two is strong enough to withstand or to prevent such flow. Remember, here is active. So now once there is surge, you will see that surge, which is a very high voltage event, can cause the breakdown of the dielectric strength or the insulation of the air between these two contacts. And then once the dielectric strength of the air is broken down, you see that charges, okay, will be forced, or current will be forced through the other part of the arcing on to ground. So once that happens, you'll see that that excessive spike or that voltage spike or excessive voltage will not go into the transformer winding. Instead, it will be clipped to ground. So that is how the arcing on works. Okay, we have other, and that is how the surge suppressors or surge arresters in bigger units, that is how they work also. Okay, these are the surge arresters, okay, in bigger units. So it's the same thing. Once there is a spike, it causes the breakdown of the insulation between here and the ground that it is connected to. And then instead of it going into the transformer, it just flows into the ground. Okay, so these are the surge arresters. Okay, we have three, one for each of the phases for larger transformers.